Hey everyone, welcome to our session. My name is Anthony, and I'm a PM on the Azure Container Apps team. And later on, I'll be joined by my colleagues, Ramya and Asir. And we're going to show you some new capabilities today that will make it even simpler and faster to build cloud-native applications on Azure using Azure Functions, Azure Spring Apps, Dapr, and a lot more. As developers, we want to build applications that take full advantage of the cloud. We want to build applications that are scalable, resilient, and secure. These applications are often built using microservices that are deployed and managed by multiple teams. Each team wants to use the technologies and tools that work best for the things that they're building. But the services they all build have to all work seamlessly together. Azure is a rich set of services for building cloud-native applications. When we deploy cloud-native applications, we often think of Kubernetes. In Azure, we can use Azure Kubernetes or AKS. But as developers, we often want to work at a higher abstraction. Azure services like Azure Container Apps, Azure Functions, and Azure Spring Apps that allow us to focus more on our code and less on our infrastructure. And of course, our applications can take full advantage of the entire Azure ecosystem, including databases and a lot of the new AI capabilities that I'm sure you've been hearing a lot about. And when we talk to our customers, we're finding that they're building applications using a combination of components. This is a great example here from Fujitsu. For each microservice that they're building, they're actually picking the best Azure service for the job. And when they do this, what they found was that their application was more resilient, more scalable, and easier to manage, which was exactly what they were looking for when they adopted a cloud-native approach. A year ago, Azure Container Apps became generally available. It's a serverless containers platform that's built on top of AKS and a bunch of other popular open source technologies. We've seen a lot of you use it already to build cloud-native applications and microservices. And we've shipped a lot of new capabilities in the last year based on a lot of your feedback, including more flexible networking, larger containers, and a new feature called Jobs that we'll talk more about tomorrow. And earlier today, we shipped a new feature in Azure Container Apps called add-ons. When we're building applications, we often need to talk to services like a database. Add-ons make it really easy to create a service like Postgres or Redis with a single command. And it happens really, really quickly. Add-ons run in your Azure Container Apps environment and integrate seamlessly with your container apps. Well, we're going to have a link at the end of the session if you want to learn more about add-ons. But right now, I want to show you how to deploy a container app. Azure Container Apps run in a container apps environment. An environment is a secure compute boundary that comes with a bunch of built-in components, like you see on the slide here. We have an ingress based on Envoy Proxy that handles routing as well as load balancing. And all the apps share common observability and logging using Azure Monitor. You can also choose to send logs to other destinations if you want. We integrate with Kata for event-driven scaling. And this allows container apps to scale based on events. And they can scale all the way down to 0 if there's nothing to do. And another component that comes with container apps is Dapr. Dapr is a popular open source project for simplifying microservices. It provides a lot of common functionality like service invocation, pub/sub, and state management. In the demo that you're about to see, we've configured Dapr to use Azure Service Bus for pub/sub and Postgres for state store. And the container app that we're going to deploy is a web application that's the front end for a music store. And let's go to my machine here. Okay, so what I have here is an ASP.NET Core Blazor server application built on .NET 7, as you can see here. And it does two things. One thing, the first thing it does is that it calls another API to retrieve a bunch of albums. And it does this using Dapper Service Invoke. And the second thing that it does is that it's able to give you some album recommendations based on what you want to listen to. And we do this using a form. And we're kind of basically collecting what you want to hear as well as your email address. And then we're kind of putting that into a pub/sub message and posting it to a pub/sub topic using Dapper. And then we have another application that we're going to see later that actually picks up this topic, or this message from the topic, and basically figures out the recommendations to give you and then emails it to you. And that's it. So it's super easy. And these are the commands that I'm going to run to deploy the app. I'm going to run it first, so we don't have to wait for it. The first command is what gets my application that's currently locally on my machine into the cloud. It's called AZ Container App Up. And I'm giving it a bunch of different parameters. The key one here is the one on the last line, which is the source, which is the current folder. So it's going to take what's in my current folder, build it in the cloud, and then deploy it to container apps in the single command. And then after that, I need to enable Dapper so that my app can take advantage of the pub/sub that I set up, as well as the service invoke. And because it's an ASP.NET Core Blazor server application, I also have to enable sticky sessions so that the Blazor application can work properly. So while that's happening, let's take a look at the Azure portal. So right now, I don't have any apps there in my Azure Container Apps environment. So we're just going to take a look around at the different things that the environment gives me. So one of the things I want to call out is certificates. You can actually upload certificates for your TLS so that any custom domains that you set up can be secured by HTTPS. And today, we actually announced a new feature called free managed certificates, so that you can actually get a free certificate for every custom domain that you set up on your container app. And here you can see the Dapper components that I've configured. So as I was saying before, pub/sub is configured using Service Bus, and the state store is configured using Postgres. And if I want to add more components to my Dapper configuration, I can now use this new experience here to actually choose the building block that I want. Say I want a binding, and I want to use SignalR service. And I can actually choose a SignalR service instance and fill out a couple more boxes, click create, and I have myself a Dapper component. So no more YAML. And now let's take a look at my apps. You can see my app has now been deployed. Let me just double check over here to make sure that my commands have finished running, and they have. So I can now click into my container app. Get rid of that error there. You didn't see that. OK, so I'll just go ahead and open up the application. And you can see that the app is deployed. It's running. But because there's no API to talk to, it's saying that there are no albums found. So let's go back to my slides. So we can really easily build out an albums API. And to do that, I'm going to bring up Asir, who's going to show you Azure Spring Apps, as well as how to build an API for our application.
Thank you. Thank you, Anthony. Hi, everybody. Thank you, Anthony. I'm really excited to talk about Azure Spring Apps. Anthony mentioned Java Spring App as the REST API controller so that you can get that data into the music store, right? So we're going to explore how Azure Spring Apps can help here. First, let me introduce myself. I'm Asir. At Microsoft, I'm a principal architect for Java on Azure. I'm on point for everything customers and developers like you to make sure that you all have everything to build, migrate, and scale Java apps on Azure as well. Right? And my journey, I started in 1995 with JDK1. I've been working with Java ever since. I've been at Microsoft for almost 18 years. And I have seen the evolution of Java, focused on Java, how it has evolved on Azure, and how it is shining training today. Let's dive into Azure Spring Apps. Right? Azure Spring Apps is a fully managed service specifically designed for Spring Apps. It allows you to focus on building the apps, particularly truly what matters to you, building and running the apps that drive your business without the hassle of managing any underlying infrastructure. And the beauty of the service is its simplicity. All you need to do is just deploy a jar or code, and Azure Spring Apps will take care of everything for you. It automatically wires up the runtime, all the complex things. It saves you a lot of time, so it just comes up and running. Once the apps are deployed, you can easily identify and fix any errors or performance, and then you can run again, deploy again, so you can rapidly improve these applications. Azure Spring Apps is also well integrated into the ecosystem. And I'm very, very proud to say that Azure Spring Apps is a result of a collaboration between two industry leaders, Microsoft and VMware. Our combined expertise has led to the joint development, operation, and support of the service, ensuring that you receive the best experience for Spring on Azure. Enterprises, they are running mission-critical Spring Apps at scale using this service. Morgan Stanley, Swiss Re, Leantis, Digital Realty, Kroger, National Life, FedEx, just to name a few of these companies. Right? Now, we work with a lot of customers, so I want to thank you all for all the feedback. I know many of our customers are here, so I want to thank you for your feedback. So we continue to listen and learn from customers, and here are some key learnings that are related to what we are going to share today. Right? So you have lots of apps that don't run constantly, and some of those apps experience bursts of traffic. You have a diverse app hosting environment where some of the Spring Apps are running on Azure Spring Apps, and your backend, your container apps, functions, they're all running, handling different types of functionalities. Now, managing the network configuration across all these hosting environments can be overwhelming, right? And you also told us very clearly you need some flexibility in configuring cores and memory for your applications. And you're also looking for easier way to getting started for all these experiences. So to address these learnings today, I'm really thrilled to announce the launch of a brand new offering. It's the standard dedicated plan for Azure Spring Apps. This new plan, it introduces the hybrid pricing, combines the best of the both worlds for you, where you can pay as you go, as well as you can have resource-based pricing, all in one comprehensive package. It provides you all the flexibility that we talked about in the earlier slide, the pain points, price predictability, significant cost savings. This way, whether you are getting started or operating at scale, you should be able to handle that. Now, the consumption and dedicated plan are now available. They're available in public preview. You can also mix and match because some of your apps will be scaled to 0. Some of the apps you want to provision in a dedicated form. So this way you can make the right choices for your applications. Right? Now, let's take a closer look at this offering to achieve, and we'll talk about what are the outcomes that you can achieve. Right? So the first one, you can get started with a consumption plan, allowing you to scale your apps from 0 and scale them back to 0 as needed when it's not in use, right? You can use this consumption plan particularly when you're running for unpredictable traffic patterns, right? And you only pay for the compute when you actually use them. You can use the dedicated plan when you need single tenancy, price predictability, significant cost savings for all your applications, right? They're all running in Azure Spring Apps. The plan offers so that you get the consistent performance and full control within your hands. Right? You can also take advantage of the flexibility to mix and match. Some of your apps can be in consumption. Some of your apps can be in dedicated. This way you can meet the exact needs for your application. Right? And you can also customize your sizing. You can go from 0.1 core to 16 cores or 0.1 gigabytes of memory to all the way up to 128 gigabytes of memory. And we talked about simplification since all of them are going to be running in the same environment. the networking part is actually simplified. Now, with the dedicated plan, along with the consumption plan, it allows you to deploy your Spring apps alongside other containerized apps, regardless of what programming language is used, whether you're using Java, Node, Python, Go, .NET Core, they all can run in the same environment. And you no longer have to deal with all the complexities of managing multiple networks, subnets, security groups for all these app types, right? You've probably dealt with all the egress control, ingress control. It can be a nightmare, but this all things come into the same network environment. It makes it really, really easy. Now, also imagine it's not just streamlines your operation here, but it also enhances the collaboration between different teams building different apps using different frameworks, right? There'll be a lot more collaboration you will see because they're all running in the same environment, right? So with that intro, let's add the Album API to the Music Store. So we're going to deploy a Spring Boot REST API controller. Right? And the Music Store app that Anthony showed us, it's going to pull the data by calling these REST APIs. And those data will come from the PostgreSQL. I'm going to switch to my machine here. All right, so you can see that there are no albums found right here, right? This is where Anthony stopped. So I'm going to go here so you can see this is a Spring Boot application. You can see that it's 2.7.1, right? Let me go straight into the controller. This is the controller. And you can see that it's a simple controller that returns all the albums right here. Now, in the interest of time, what I'm going to do is I'm going to start the deployment, and then I'm going to start explaining how I'm actually doing it, right? So what I'm going to do here is just deploy. So this is the command I'm going to use. You can see that it says AZ Spring App, deploy my app. The name is there. Name is the Album API. And it's giving the jar file, the location of the jar file. I'm also choosing a specific Java runtime right here. Now, let this start while we go back to the portal and see how I actually got this all started. Right? So here, if I go here, right, I have to start from scratch, right? So I have to first say I want Spring Apps, right? So when I choose this, what happens is I can then quickly come to this screen. I can actually start the creation process right here. And that will take me straight to this particular screen. So here in Portal, I can say I want to create a Azure Spring Apps. I specify my subscription, I specify the name, and this is where I'm choosing a flexible consumption as well as dedicated right there. I'm choosing the Europe, and I'm choosing the underlying app environment as well. So with this, I should be able to create. I can go through filling up all these, or I can take the defaults, right? And then I can review and create. In the interest of time, I already created it. It's right here. So this is Azure Spring Apps, and you can see the tier is right here, and this is the subscription where I'm using it. Now I can go into the apps as well. So let me go into this apps right here, and you can see the apps is right here, and I have one app. It's the API app. Now I'll also show you how I'm going to create this one app, right? So the way I would do is I would click on Create App. Once I create app, I'll come to this page. So I can say I want Album API 2, right? It's Java. I chose the environment. And I can come back and set these values, right? Now here, I can choose the profile. So this is where the flexibility you see. I can choose either a consumption or a dedicated. Let's say I choose consumption to start with, right? And then I can choose from these ranges here, right? Now, if I were to choose this as dedicated, and now I can actually have a lot more control, see? I can choose, for example, 3.1, something like this, and then maybe somewhere around, say, 6 or 8 or 10, how much ever I want. And then I can set how many replicas I want, and then I will just start the create. Now, once I create, suddenly it'll be like this, right? This is the This is the API app. Now, before we continue, I want to check how the demo is running there. So let me go to that screen. Oops. OK, let me go back to that screen. Here is the screen. Right? Oh, it completed that thing. So you can see what happened here is it took my code, it put it in, and it started the deployment, and the deployment is successful. So let's check how it went through. So I'm going back here, and this is where we left off. So I'm going to do a reload on this. There you go. The REST API is up and running at this point. And you can see that the data is coming from Postgres, exactly the setup that Anthony was explaining to us, right? I do want to show one more thing before I project to the slide deck there. All right. So if I go into this API right here, you can see that I can scale up right there. I can also scale out. I can also configure whatever I want, and I can also set up custom domain. All of these are in my fine-grained control for me so that I can handle it. Going back to the slide deck now. All right, with that, what we have done is we've added a REST API using Spring into the Azure Spring Apps. And there's a .NET, ASP.NET app that's now talking to the REST API controller in the same environment. It's almost like neighbors talking to each other, right? And now that we have an end-to-end app that resembles a line of business or externally facing application, right? What we're going to do is we're going to infuse some intelligence into it with AI. So you can imagine how you can add perception capability, language capability, and autonomy into this app. Ramya is going to show that. Ramya?
I'm going to talk about event-driven cloud-native apps using or implementing AI models using Azure Functions. Hello, everyone. I'm Ramya Urganti. I work as a PM in Azure Functions team. I'm super excited to share some new updates in the Azure Functions service. So Azure Functions is a serverless solution. It provides an edge compute where you could write code in the language of your choice. You can connect to various services using the triggers and bindings that are available out of the box using the Azure Functions extensions. So you need not hard code any integrations to the services. So Azure Functions also provides an end-to-end development experience with both the inner loop and the outer loop experience, right? So you could code, build, debug, deploy, and monitor your function apps. So Azure Functions provides multiple hosting options. You could build once and deploy to multiple destinations. There are several plans that are available in Azure Functions, right? Like consumption plan, elastic premium plan, dedicated app service plan. Or you could deploy Azure Functions to Kubernetes or AKS clusters using the open source Azure Functions host images. And finally, Azure Functions can scale per demand as per the load, and you pay for the compute that's being used. So as you can see, the entire underlying layer is being managed, so you need not worry about maintaining the service. I'm super happy to announce the public preview launch of event-driven serverless Azure Functions for microservices. So this is going to enable you to deploy Azure Functions on this managed microservices environment easily and quickly. It also has the flexibility to run functions along with other microservices, websites, workflows, or any container-hosted programs. So you could write the code, the functions code in the language of your choice. You could leverage the triggers and bindings. And it also provides with end-to-end development experience, right? So in the cloud-native space, the DevOps processes and tools are used to manage the cloud-native apps. And Azure Functions already supports that. So with Azure Functions for microservices can be deployed from code to the cloud using all of the DevOps tooling that Azure Functions supports. Like say, for example, you could deploy using GitHub Actions or Azure DevOps pipelines. And finally, you can easily integrate with other microservice apps. Let's say you have a web app, a function app, and a backend DB, all of them hosted on containers. And you could integrate them and deploy at one go using ARM templates or Bicep templates. And on the other hand, with Dapr, you can actually integrate these microservices together and use the best practices with respect to secure connectivity between microservices, or you could even use the features available from Dapr like resiliency and observability. And here, the underlying layer is completely managed, and things like the features like networking and observability are all managed at an environment level, and the apps and the microservices are within the environment are going to share these configurations. Okay, from scaling standpoint, you could scale these function apps all the way to 0 when there is no load, and you can scale to tons of functions containers when there is heavy load. And you pay per compute, and this is possible using the consumption plan. Optionally, you can also set min replica count to 1, where a functions container is always running, and you could pay per idle price when the replica is inactive. And there is no extra charge for running Azure Functions on container apps because the functions executions are built by the number of container apps that are being executed. So as you can see, the scaling is enabled in such a way that it scales all the way to 0 and to loads of or to tons of containers. So this is possible using Keda, because so how scaling happens? It's due to the events and events that are flowing into these event sources like Kafka or Service Bus or Event Hubs. So Keda helps with scaling the function app containers based on the events that are loading into these event sources. And with the seamless integration between Keda and function apps, you need not configure scaled objects or CRDs. So functions takes care of that. So as you can see, most of the capabilities we are trying to bring in to kind of quickly get you started and deploy your function apps and accelerate your agility to bring the function apps and deploy them onto this environment. Right, so let me go back to the Music Store app. So you've seen Anthony deploy the Music Store app, which is a web app. It has a UI interface. It loads in the albums. It also takes the inputs from the user. And then you've seen Asir deploy the album API, which is retrieving the albums from the PostgreSQL. So let's say there is a request that the user is having, and we need an app which serves the request event. And functions can be put to use here. So I'm going to use the recommendations functions app, which is essentially going to take the request, that's the message that is going to be published by the Music Store into the Service Bus topic. Now using Dapr topic trigger, it subscribes to the Service Bus topic, and this is using the Dapr extension for functions. So once the request has been picked up or consumed by the function app, it invokes the album API to pull in the list of albums, and then finally invokes the ChatGPT AI model that is hosted on Azure OpenAI service. So this is going to run the model and retrieve top recommendations for the user, and finally send an email to the user using the Azure Communication Services. So let's see things in action now. I'm going to head back to the demo zone. Okay, so I have the function app here. So it first calls the search event, which is essentially having the trigger data, which is coming from the Dapr topic trigger that is subscribed to this topic called searches, and populates the search event with the trigger data such as email of the user and the request. Then the function app is going to call the get albums service. So the get album service is essentially going to call the album API, which is hosted on Spring App Service, and returns the list of albums. And then it invokes the OpenAI API and provides the input as the list of albums and the request that's come from the user, and runs the model here. So the output of the model is then returned to the data, and in the form of an email. It uses the Azure Communication Service to send an email to the user. So this function app is already containerized, and I've uploaded this into the container registry. So let me go ahead and show you how to deploy this using AZ function app create. So in this command, I'm sure you're already familiar with this. So we have added a new parameter called environment. So this is where you define the target destination to deploy your function app. And then provide the image, which is the container repository URL, where the image is hosted, and the username and the password. So Azure Functions for Microservices supports both public and private repositories. So if it's a private repository, you're expected to provide the credentials. So let me go ahead and execute this. So while this is executing, so Azure Functions for Microservices can be deployed using various tools like AZ-CLI, Azure Portal, Func Core Tools, GitHub Actions, and AZ DevOps Pipeline Tasks. So now I'm going to show you how to deploy the function app using Portal. So this is the create function app experience. So I'm going to go ahead and give the subscription and choose a resource group. Okay, and then give a function app name to this. And I'm going to select the mode as container because I'm going to deploy a container image. And go ahead and choose a region. And choose the plan, which is Azure Container Apps Environment Plan. And then finally choose the environment. So here I can either choose an existing environment or pick from the or create a new environment. So the create new essentially takes me to a create container apps environment experience. So here you could give the environment name, and this is where you choose the plan, which is consumption. You could select or create a new log analytics workspace to monitor your container logs. And from a networking standpoint, you could either choose or bring your own network, which could be either a public network or a private network, or pick the one that Container Apps provides already. Okay, so for this demo, I'm going to go ahead and choose the existing environment. Then choose a storage account, stick with the default, and make sure you enable the App Insights because this is going to help with monitoring your function apps. And from a deployment standpoint, you could either choose a quick start image or give your image URL either from a public repository or a private repository. So if it's a private repository, you're expected to provide the login server username and password as well. So I'm going to go ahead and choose a quick start image. And this is a new experience that we have introduced in Azure Functions for Microservices. So this has a HTTP sample. So on successful deployment of this function app, the HTTP sample is there running for you, so you can test it out, invoke the HTTP endpoint. Okay, so let me go ahead and create this function app. So while the deployment is happening, let us go back to our AZ-CLI deployment of the recommendation service. Okay, so the function is created, right? It has successfully deployed. So if you notice, the function app is actually talking to two services, right? Like the OpenAI service and the Azure Communication Service. So we need to set the function app settings. So this can be set using AZ-CLI, or you could use Portal. Since they are secrets, I'm going to show you an existing app which is already configured with these app settings using the Portal. So here it is. So these are already configured. You can give more app settings as the app needs. Okay, so now it's time for it's showtime actually, right? So let's go ahead and click on check out our music store. Okay, I see some good list of albums. Let me go ahead and provide a genre, grunge. I've learned that this is a native Seattle music genre. So let me get some recommendations here. I'm gonna click on send. So this is where function gets invoked. It picks a request from the service bus topic and runs the model and sends an email using the Azure Communication Service. All right, so I got an email and a bunch of recommendations for this genre. Great. So I'm going to head back to the slides and show you what we have just done. So you've seen how easy and simple it is to deploy these microservices onto this environment. So there is no need to learn about or know about the underlying or interact with the underlying Kubernetes API layer or learn about deploying the container app images, right? So you're using the interfaces and tooling that you already deploy using Azure Function Apps or Spring Apps. So the same interfaces and tooling are used to deploy these containers into this environment. And the other thing to note is that we're using Dapr. So Dapr helps with weaving those microservices together. It also helps with providing the traces of traffic and determines the dependencies between these microservices and also gives service insights. So wouldn't it be good to view these service dependencies through an observability tool, right? So Asar, you want to show us that? Yeah, thanks.
Right. In the interest of time, to speed up, I'm going to go straight to the demo now. I'm going to switch to my machine. All right, so here it is. So you saw the app in the diagram, right? So now you're seeing it in the tool application insight. Everything is wired up for you. You don't have to do anything. If you don't want it, you can deactivate it, right? But everybody wants this. That's what people tell me, right? So if I go deeper into this, right, you can see various pieces here. For example, the recommendation services. Recommendation services right here. And you can see the album API, REST API is right here. You can see the music store. And you can see the calls going through Dapr to the database. And you can also see the calls going into the pub sub engine right here, right? Now, we can go deeper right here. So if I click on one of them, right, I can actually investigate its performance here. As I go deeper, right, I can see all the calls going in right here. And you can see that there are about 4,000 calls have gone through it. I can drill into the samples. So one of the things I drilled up is this one. At this point, it's going to bring the end-to-end transaction for me, right? You can see the end-to-end transaction that's happening right here. Now, I can also see all the calls that went in here, right? So I can do the same kind of drill from the performance blade. I can also look at the dependencies. So these are all the dependencies from the call that came in. So here are all the dependencies. So I'm going to choose one of them right here, right? When I choose this, I can also drill straight in. And once I drill straight in, now it's going to show me the complete end-to-end transaction, right? Now, you saw me drill into one of the calls that coming in through dependencies. You can also see the exceptions, and you can drill in and figure out exact stack trace that actually came through as well, right? So it's an easy way. You don't have to do anything. Everything is wired up, and you can quickly get to the thing, right? I'm going to switch back to the slides here. Right. So every one of you here, you can focus on the code, right? you can deploy any app type, advance them to production without worrying about the underlying infrastructure. You can deploy to container apps, you can deploy to Spring apps, you can deploy to functions, right? Or any app type because of the container apps there, right? You can build and scale app workloads at cloud scale. You can easily apply all the cloud native patterns. You get the full power of Kubernetes, right? And without even touching Kubernetes at all. You didn't have to learn. You don't have to do anything with it. Now, you will love it because you're going to focus on your code, like the business logic, not the infrastructure. This way, you can go to production faster and go to the market faster. You can scale out, scale up, scale in. Everything you can do it very easily. Everything is secure by default, and it's all within your control. Your ops team will also love it, right? Because there's a common compute boundary which gives them centralized networking, centralized billing, centralized observability. Your leadership team, they will also love it because you can go to market faster. You can finish your project faster, faster time to market, and it also gives you lots of headroom to grow so that you can deploy more and more apps. So when you are getting on your app modernization journey, choose this, choose all of this, right? So that it'll be easy for you to get there, right? Now, you can get started today, right? You can deploy container apps, you can deploy Spring apps or Azure Functions. All the announcements, the links are right there. You can scan them, you can read more about all these announcements that we discussed today and get started right away. With that, I'm going to invite Anthony and Ramya back to the stage so we can answer some questions that came in through here. Right. So the first question we have is, why choose Azure Spring Apps over other options like AKS, things like that, right? I'm going to take this question. So in Azure, we have beautiful services at different levels. We have an amazing Azure virtual platform, virtual machine platform. We have amazing container platform called as Azure Kubernetes Service. And then we have Azure Spring Apps, right? So they are all different levels of abstraction. So virtual machine, container platform, Azure Spring App is an app platform, right? They're all different levels of abstraction at different levels of abstraction for you to help, right? Now, all of these are great services. Now, which one should I use goes back to clearly what your requirements are, right? What are your scenarios, right? If you have a team that needs to go to market fast and they have all the apps that they need to just deploy and everything else is taken care for them, then certainly Azure Spring Apps will help them, right? Now, Azure Spring Apps is also built on top of Kubernetes as well. So anybody can build it. Now, when you're choosing the container platform, then you will be on point for everything that we do inside Azure. For example, source to containers will be yours, auto patching, auto scaling, many of the security wiring, monitoring wiring, all of those you will have. So it's a different levels of abstraction. Then it goes back to you'll have to check what are your requirements, what kind of skill set you have, what levels of abstraction that you have to pick. Right? So that way you can choose whichever is correct for you. So the second question, you want to?
So the second question goes, when should I use Azure Functions instead of Azure Spring Apps? So Azure Functions is built for event-driven programming, right? If you have to connect to various services or event sources, and if the function or the app needs to be executed based on some events that are happening on these event sources, that's when you use Azure Functions. But then if you want to write Java apps, purely, which could be web apps or backend apps, which is always running, and that's when you could host it on the Azure Spring App Service. Next.
Okay. I think that concludes our questions. So we want to thank everybody for today. Thank you for joining us and being here.